Okay, this time the LSP will be running from router 1 to router 7, and of course we're going to have one on the return path from router 7 to router 1. The similar things apply when it comes to the CSPF from router 1, same as it was before. We want this to be adaptive so that the bandwidth is only counted once, and we would like there to be two paths on both LSPs, and the paths we'd like to be diverse. So what we're going to do here is we'd like the paths pre-signaled, and we would like them to not revert if there's a failure. So here on router 1 we've got two secondary paths on our LSP, and because they're secondary rather than primary and secondary, it means that it's not going to revert back to the primary path because of course neither of them is primary. So on a failure, when it re-signals onto the other path, it's not going to fold back onto the original. We want the pre-signal, hence the standby, and we're going to manually select one of them here so that there is effectively not a primary path, but we're manually selecting the one that we want. Now, in order to do that, obviously we have two paths on the LSP, and they're router 6, router 4, router 7. So we've got this direction, router 6, router 4, router 7, and then the diversity routed path goes router 5, router 3, router 7. And so they're configured there with loose hops here for the ERO. So the first one, 6 and 4, and the second one, 5 and 3. Then on the reverse path, going the other direction, the LSP going the other way, again, we've got two standby paths. We're going to be selecting one of them as manual. Obviously these have different names and descriptions, and we've got the two hops loose on each of them. So from router 7 we've got 3 and 5 loose, and that will take the top path, come down to router 1, and then on the other secondary path we have 4 and 6 loose, and it will take the bottom path. So the next two label switch paths are from router 5 to router 3, and then the return path from router 3 to router 5. Now on the path from router 5 to router 3, it's starting to get interesting because the secondary path of this LSP is using admin groups. Now the primary path going from router 5 to router 3 really has no restrictions on it. So you could almost call it like a name placeholder, because of course it's there, but there's nothing configured on it. Notice also we drifted slightly from our naming convention with the primary path having the 2 in it. Anyway, so it's a secondary path that are using the admin groups, and we've specified here to include any of gold or bronze. So if either gold or bronze was available, we can use it. However, we can't use silver. So this path is running from 5 to 3, and what we're basically saying is if the primary path wasn't working, you could go gold, and you couldn't go bronze here because silver was present, so you would have to go gold, gold and bronze. So there's a restriction on that secondary path. And as we can see here, both primary and secondary are defined. Now on the label switch path going the other direction, again the restriction is on the secondary path. So from router 3 to router 5, which is the return path, we have of course the obligatory IP address here. We then have primary and secondary, and on the secondary we have a hop limit of 2, which is going to restrict the number of hops that it can use to provide backup to router 5. However, notice that on the return path we're not using the admin groups. So before we move into LTP tunneling, the last two LSPs that we need to configure are from router 3 to router 7 and router 7 to router 3. And again, this is just a single hop, so it does get quite interesting. So obviously we configure the label switch path with the IP address, and on this one from router 3 to router 7 we're going to have node link protection, which means that obviously if the path was to fail here or the node was to appear down router 3 would signal a different direction. Now we've been asked to make sure that router 5 and router 6 are not used as transit nodes. And the way that we're going to do this is we're going to restrict the hop count on the link protection. And you might think that it would be one hop through router 5, one hop through router 4 to get to router 7, which would basically break the rule of router 5 being a transit node. But in fact, even though this is node link protection, the hop count here are the links. And what we're basically saying is that's a hop and this is a hop. And that's why setting the hop limit to 2 on the link protection under RSVP notice fulfills the criteria. So in summary, what we have here is we have an LSP from router 3 to router 7, a corresponding LSP from router 7 back to router 3. We're turning on node link protection, and we're making sure that router 5 and router 6 are excluded from that backup path by setting the hop limit on the link protection inside the RSVP interface to 2. We've been asked to optimize the LSP paths. If the LSP path has been signaled by the CSPF algorithm and perhaps there's been a topology change, then by setting the optimized timer, the LSPs can refresh themselves with the new CSPF information. Command set protocols MPLS optimize timer, and then here we've set this to 7200, which is 2 hours.